Hi guys, I'm Darshan. Today I'm here to explain about the lab set number 8, which is under Ddco, Digital Design and Computer Organization. In this lab set, we are going to stimulate HDL Verilog code to implement various types of flip-flops, that is JK flip-flop, SR flip-flop and D flip-flops. Okay, the question is like this. Design Verilog program for implementing various types of flip-flops such as SR flip-flops, JK flip-flops and D flip-flops. Before going to this, let us know about some basic information about flip-flops. Okay, then here it is the definition of the flip-flops. Flip-flops are basic building blocks of sequential circuits. They are used to store one-bit data and depend on both current input and previous states. It means what? The first way we should know about sequential circuits. Sequential circuits. It means that let's assume we have two gates in the circuit. Both are two input gates. For those gates, one of the input is taken directly, and the another input is dependent on the output of the other gate. These types of circuits are called sequential circuits. And another word I am using, basic building blocks. We all know the basic storage unit in the CPU or computer is called as registers. For the building purpose of the register, the n number of flip flops are used. So I am using the word basic building blocks. In our syllabus, they mentioned three types of flip flops: SR flip flop, JK flip flop, and D flip flop. Here I mentioned some important key points about these types. First is SR flip-flop. It means set and reset functionality. It performs set and reset functionality. JK flip-flop is usually avoids SR's flip-flop's invalid state and adds tag link. In D flip-flop, it ensures the clean data transfer. Okay, then we see SR flip-flop. It has two inputs, S set and R reset. The behavior is as follows. I am mentioned below the truth table and the circuit diagram for the SR flip-flop. Here let's take the example as 1 0. For S I am giving 1 and R I am giving 0. And the clock it should be 1. We usually prefer 1 as the clock. Here I am giving S1 and R is 0. 0. Okay, here 1, and for NAND gate both inputs are 1, output will be 0, and 1 0 it should be 1. For this NAND gate, one output is 0, then obviously the output will be 1. This one is going to input for this one 1, and this one 1 1, it will become 0. Here I mentioned 1 for the value of Q. That means Q is set as 1 for this flip-flop. Accordingly, the 0 1, when I give 0 1 for this table, all the things are happen, then we will found the value for the Q is 0, that is reset. And when we give both values 0 0, then will it not change anything, no change in the value of Q. We can't give 1 1 for this SR flip-flop, it will invalid. We shall move to the code. The module name is SRFF and the parameters are SRQ, QB, CLK, RST. That means S and R are the inputs, set and the reset. QB is the complement of Q, that's Q bar, and the clock and the reset. Here the inputs are SR clock and reset. Outputs are Q and Q bar. Here we are using Q and Q bar as the registers. Here the actual code is starts always at positive edge of clock. If reset Q, that means when we provide 1 for the reset, it will reset the value for Q as 0. Then the else part is begin. Uh, when we provide SR as 0 0, Q will be unchanged. When we provide 0 and 1, that means 0 for S and 1 for R, Q will become 0. When we provide 1 for S and 0 for R, it will become 1. And when we provide both inputs at 1, we all came to know that is invalid invalid input. This is the code assigning Q bar to the QB. Let's move to the output. Here we can observe R is 0, clock is 0 and reset is 1. Here we can observe the whole output for this code. Here, the module name is JKFF. The input and outputs are JKQ, Q bar, CLK, that's clock and reset. Here the inputs are JK, clock and the reset. Output are Q and Q bar. Here we are using two registers, Q and Q bar. Here it is the code always at positive edge of clock. When this condition is true, it's begin with the if statement. If the reset is set to the 1, the output will be 0. Else this part is going to run. When we provide the input as 0 0, there is no change, Q will be same. When we provide input as 0 and 1, I mean 0 for J and 1 for K, the Q will becomes 0, and when we provide 1 0, Q will become 1, and both the inputs are 1. The output will be Q bar, that is complement of Q. This is called toggle. The case is end. Then we assign Q bar QB is not of Q. Here it is, the code is end. Module will be ended. We'll move to the output of this code. Okay, here it is the output for the JK flip-flop. Here we provided both the JK input as 0, clock is set to 0 and reset will be 1. For this code XX, it is the output for this JK flip-flop. Here we can. Okay, now it's time to know about D flip-flop. Here the code is like this. The module name is DFF, and the DQ, QB, CLK and reset. Here the inputs are D, clock and reset. Outputs are Q and QB. Q and QB will be the registers in this code. And here the next part is like this. Always at positive edge of clock, that is usually 1. It's begin. If reset is when we provide 1, it will reset the value of Q as 0. Here else part is begin. Case, there are only two cases. We know, as we all know, for this D flip-flop only one input will be there. If the case or two cases are there, if we provide 0 as input, the output value for the Q is 0. If we provide 1, Q will be 1. Here we can observe the values are input D equals to 0, clock 0 and reset is 1. Here we can observe the whole output for this code. Thank you. This was my video, and I hope you learned something from this video. Thank you.